Okay, so that mumbo jumbo about epsilons and deltas, here's what the picture looks like so that you can connect what the words epsilon and delta are actually doing. So in this one, what it's saying is, here's the number c, and remember in a limit, I don't have to touch that number, but I have to be able to get as close as I want. How close? Well, that's what delta represents. Delta represents how far from that number I'm actually going to be. Okay? Same thing up here, at that actual number, like we've been seeing, there might be a hole in the graph. How close do I want to be to that actual value? Well, if L is the limit, like maybe that's the number 3, then this is L plus epsilon, L minus. This is the region here. How far away I am is epsilon from that real value. So the reason that there's this weirdness happening is because you don't have to be exactly on the value. We have to find a formal way to say just how close we want to be. So for example, if somebody said here, I want to be 0.01, then that would leave us with the question, how close do you have to be down there in order to be within 0.01 here? Now this is something that would be done in industry all the time, right? Say you're building a gold refinery, and you say to your boss, well, if you want gold that's 99% pure, well then it's going to cost you within $1 million to build this refinery. And then they say, no, it has to be 99.9% pure. And you say, okay, but then it's going to cost you $5 million, right? Figuring out how close you have to get to an exact value, I mean, that's something that comes up quite often, because you're not actually going to be able to produce it. Anyways, so what I'm going to do is I'm just going to walk you through this proof here, and there's a picture in the margin that I'll talk about when I'm done. So the proof for this one is to show that the limit as x goes to 1 of 5x minus 3 equals to 2. Now let me just be clear that there's no good reason in the world why you'd ever do this in practice, okay? But it's got to be simple because this is a complicated idea. Now, you always need to build a strong foundation before you can go further. So when mathematicians were starting calculus and they came up with the idea of a limit, they had to say, well, it's really tough to get any progress unless we know exactly what a limit is. If I can't tell you exactly what a limit is, how am I going to progress? I might be able to tell you 60% of what it is, or I might have a vague idea, but vague ideas and 60%, that doesn't really fly in the math world, right? We want to know so that we can take that knowledge and move forward. So I'm going to show you how we could actually prove this using the idea of a limit. Okay, so here's what I'm going to do first. I'm going to say I need to figure out if I want to get close to, how close to 1, given some accuracy you give me for 2. So here's how I'm going to set up my proof. First, I need to do a little bit of rough work. I need to think, let me just, I think I'm going to have to probably, I'm going to write it out a little bigger. So I'm going to just show you my rough work here. Okay. So we're going limit as x goes to 1 of 5x minus 3 equals to 2. So in my rough work, this is what I'm trying to tell myself. I'm thinking ahead to the person who's going to challenge me to come up with a value. And I will say, well, let's suppose that I'm within epsilon. Okay, I know it's a weird concept, but this is what it's going to look like then. 2 minus epsilon will be less than 5x minus 3 and be less than 2 plus epsilon. Okay? So I will suppose that this is where I am right now. Okay? That I am within the tolerance that they are asking for. I'm going to work backwards to figure out where I have to be within x. So what that means is I'm going to add 3 to both to all parts of this inequality. I will be at 5 minus epsilon less than 5x less than 5 plus epsilon. And then I'm going to divide everybody by 5. So 1 minus epsilon over 5 would be less than x, would be less than 1 plus epsilon over 5. So can anybody tell me how close I am to the value 1? Okay. How close is x to the value 1 in that last inequality?
Epsilon over 5.
It's within epsilon over 5. So if I want to guarantee that this is how far away I am from the number you give me, that's how closely I have to be. If you give me a half, I have to be within 0.1. If you give me 5, I have to be within 1. So the way I would do my proof then is I would say, let me just go back to the other oops. To do my proof, I would go back here, and I would say, let epsilon be greater than 0. We don't think about negatives for this. Then I'm going to say choose delta equal to epsilon over 5. And what I'm going to do is I'm going to show that if you're within epsilon over 5, that the limit will be within epsilon. Okay, okay, so now if I was at, just a second here, I'm just running if I'm going to run out of room. Well, I'll try it and see how far. I may need to go into the next example here, but that's okay. Okay, so first of all, let's go within epsilon. So, sorry, just 1 second. Okay, so here's what I'm going to say then. I'm going to say suppose that what is true is that I am at 1 minus epsilon over 5 to 1 plus epsilon over 5. Sorry, I've jumped a step. Okay, so what I'm supposing is that I'm within that number delta. So now I'm going to show you that if you are within delta, that your answer will be within epsilon, that I'm playing the game that you're asking. So if that's true, then 1 minus epsilon over 5 would be less than x, would be less than 1 plus epsilon over 5. And I'm working backwards here to get the original answer. So I'm going to multiply everybody by 5. Okay, and then finally, I'm going to subtract 3 from everybody. Oops, sorry, I forgot that. So I'm going to have 2 minus epsilon is less than 5x minus 3 is less than 2 plus epsilon. So what this says is that as long as you're within that number I give you, you will end up here, which is within epsilon of 2. Okay? And I know that it's a weird process, and especially the first time you see it. So we're going to try it for a couple others together just to see if we can figure out how to do these epsilon delta proofs. Okay? So what it's saying here in this last step is 5x minus 3 is within epsilon of 2. So we're going to work out the second one, 2x minus 5 equals 1. And I'm going to leave this up here as a guideline for you. So see if you can tell me how to choose delta. This is your rough work. You're trying to figure out if somebody wants me within a certain range, what value of delta would I pick? Okay, so I'll let you try it for this one. Okay, so let's try this one here. I'll do it on the... Okay, so we're looking at the limit as x goes to 3 of 2x, what was it, minus 5? And we want to show it equals to 1. So again, first you have to figure out a way of picking your delta. So I work backwards and I say my goal is to show that I'm within some number epsilon of 1. So I'm going to write that out as 1 minus epsilon is going to be 2x minus 5 and 1 plus epsilon. I'm within that tolerance I was given. So for example, maybe you said epsilon equals 0.5. I'm trying to figure out how to get my answer between 0.5 and 1.5 within a half of what the real value is. Okay, I can of course make that epsilon as small as I want. I could make it at 0.00000000001, and I should still be able to give you a number. Okay, so I have to figure out how to get back to x from here, which is why I'm working backwards. So what I'm going to do is add 5 to this inequality, and then I'm going to divide by 2. For simple lines, this pattern will work. Whoops, sorry, I don't know how a positive got in there, but for simple lines, this will work. Okay, and it tells me that right now the value x is very close to 3. 3 minus epsilon over 2, 3 plus epsilon over 2. So if I had a number line, this is what it would look like. Here's x. Here's 3 minus epsilon over 2. Here's 3 plus epsilon over 2. So as long as I'm somewhere in here, then this would be true at the top. That's how closely I have to choose my value. Have to choose it within a half an epsilon. Okay, so now I know what value to choose. I'm going to go back and figure out, let's see here. And of course I'm going to run out of space here. I'll put it on a new note. So in this one I would say let epsilon be greater than 0. And I'm going to say choose, that's chose, choose delta equal to epsilon over 2. Okay. Now I'm going to show you that if you play by my rule, I will be as accurate as you want me to be. So here's the thing I'm going to say now. Suppose that you play by my rule and I'm within, oh, sorry, it was 3, right? Suppose that x is in that region, and of course, I don't know why I keep skipping that one. I'm supposed to start with it as the delta. Okay. So suppose that I'm within that region on the number line. So again, I'll show you that picture quickly. If this is the number 3, this is 3 minus delta, this is 3 plus delta. So as long as I'm somewhere in the middle here, I can show you that you'll be within that tolerance that you're looking for, that epsilon. So the way I'm going to do that is I'm going to go the opposite order I did to find my delta. So I'm going to say, let's start here by adding 5, or was it subtracting 5? I can't remember now. Oh, we're going to, okay, so first we use a 2, so that means I'm going to multiply everybody by 2. So I end up with 6 minus epsilon is less than 2x is less than 6 plus epsilon. And then I had to subtract 5. Was it 5? Am I? Yes. So what I'm saying is if you started here that close to the value 3, somewhere between 3 minus delta and 3 plus delta, here's where the graph, this is the graph will end up within epsilon of 1. So I'm saying that if you give me a number, now I have a way of showing you how closely I can get to the limit. So any value you give me, I can follow that pattern. If you want the graph to be within, I don't know, 0.008, if you said I would like this graph to be accurate to 0.0008, then I would know that delta has to be 0.0004. That's how close I have to be to the number 3. Okay? So again, don't fixate yourself on epsilon delta. All I'm going to ask that you do as a part of the homework is try one of them to do for homework. Okay? But it's not something that the AP exam is going to test you on, but it will be a next year's topic in university, and I will stick to these basic ones of lines in our course. I won't go any more complicated than a line like we just did. So I'll expect you to tell me how to choose a value of delta and show me that that delta puts you within that tolerance. Okay, so we don't have more time to unfortunately go along with this. I'm going to have to stop it here. If you do have questions, you can talk to me about it later.